All right, 2.7, use absolute value functions. And transformations. So I'm going to do a quick refresher from your notes for you. So we had y equals a times x minus h in the absolute value, and then plus k. The h tells you if it's going left or right. It goes opposite the direction of the sign. K is up or down. It goes the same direction as the sign. And then A tells you if it is a stretch or compress. If the absolute value of A is greater than 1, it's stretched. If the absolute value of A is less than 1, it is compressed. So that basically means if it is a decimal or a fraction, it is compressed. Okay. If there's a negative sign in front of the A, then it is reflected. So those are going to be the things that we're doing. So we're not actually graphing in this section. We are just talking about how the graph has been shifted from the parent function of y equals the absolute value of x. Okay. And this procedure generally is going to follow when we get to parabolas in chapter 4 and even trig functions in chapter 13 and 14. But like the process of like if it's inside the parentheses, or in this case the absolute value, it tells you if it's going left or right. If it's outside, it's telling you if it's going up or down, and then a number in front is always going to tell you if it's a stretch or compress, and if there's a negative, it's going to tell you that it's reflected no matter what type of a function we're dealing with. Okay, so if you memorize this stuff now, generally, you should be fine as we move on. All right. Graph the function, compare the graph with the graph of y equals the absolute value of x. All we're doing is the compare part. So number 4, y equals the absolute value of x plus 2. So this one, I have x plus 2, and so that's inside of that. So this is going to tell me if it is a shift to the left or the right. It goes opposite the direction of the sign. So since this is positive, this is going to be going left 2. And that's all you have to put. Six. F of x is equal to the absolute value of x minus 1, and then outside plus 4. So inside the absolute value, I've got a minus 1. We go opposite the direction of the sign, so that means I'm going to be going right 1. And then when I'm outside, I go the same direction as the sign, up or down, so this one is up 4. Eight. F of x is equal to negative 3 times the absolute value of x. So anytime you see a negative out front, you should automatically start out saying it's reflected. So that's the first thing I know about this one. And then I've got a 3 out front, okay? So the reason we put the absolute value when I did this A up here is because people tend to get confused and they're like, oh, it's negative, it must be compressed. Well, that's not the case, okay? So if the absolute value of this number is greater than 1, then it is stretched. Now, the way that I keep straight that compressed are like fractions is that C and F are closer to each other in the alphabet, and so that's what helps me keep them straight. If you find a different way that helps you, or you just straight up memorize it and maybe you're not confused, then wonderful. But I tend to mix them up, so. 10. Y equals 3/4 times the absolute value of x. So what's happening to this one?
It's compressed.
Yep. Compressed, and that is it. Let's get to one that has more stuff with it. Okay, 12. F of x is equal to -4 times the absolute value of x plus 2, and then minus 3. All right, so this one has a lot. Let's see if y'all can take what we've done on the ones that don't have as much and apply them here and tell me what's going on with this one. Right off the bat, what does the negative sign out front tell me? Reflected. What else do I know about this function? Left 2. Yep, inside is opposite the direction of the sign, so left 2.
Down 3.
Down 3, same direction as the sign. Yep, and it is stretched because that would be a whole number, or number bigger than 1. Now, I could take all of this information and put it on a graph. I'm just not asking you to do that because your calculator can graph this for you if we really needed it graphed, basically. 14. F of x equals 1/4 times the absolute value of x minus 4, and then plus 3. So what have we got going on with this one?
Compressed.
What'd you say?
Compressed.
Yep.
Right 4.
Yep.
Up 3.
Yes. So it's compressed because we got a fraction, right 4, opposite the direction of the sign, and then outside same direction as the sign, so up 3. All right, you're going to, for these next few, need to open your book to page 127 so that we can look at these. In this case, they are giving you a graph, okay? And you need to write what is happening to the graph.
Like in the same form?
Well, yes, but we're going to write the equation of the graph in this case. So what might be helpful is to say, okay, well, it was shifted this far over, and then it, we'll kind of just talk through that part. So a normal absolute value graph, I don't remember if there was one in your notes or not, is basically if I just have y as the absolute value of x. This looks like basically a V, and so there's a point at, let me do it to 4. So there's a point at 0, then there's a point at 1, 1, and at negative 1, 1. At 2, 2, and at negative 2, 2. Okay, and it keeps on going like that, and it makes a V. Okay. So I'm looking at what has happened to the graph to get it to the picture that's in your book from this original state. Okay. So, number 16, we're looking at that graph. Basically, if you look at it, I can't put my book up there because there's dots on it, or it's not dots, there's answers. So if you look at the graph, basically they have taken their graph and they have, it's over here, but they show you there's like a point here and a point here. They're showing you that that's one spot away like I did over here. Okay, now this is obviously not in the same spot theirs is, but that's telling you that nothing is happening to it as far as it being compressed or stretched. Because if they weren't basically a 1-to-1, then something would be happening to it. And the way we would find that is by looking at the slope of the line. But we're not doing that at the moment. This one doesn't have that. So this graph looks like it has gone to the right 4. So I would just note that. Huh?
Never mind.
Oh, I did have it on at first. So I was like, then I was like, do I still have it on? So this graph has gone to the right 4, and then it has also gone up 1, 2, 3. So a normal absolute value graph is obviously y equals the absolute value of x. So I need to take what has happened to this graph, the picture that I'm looking at, and basically add into that original equation what's going on with this one. So if it has gone right 4, where does that go in my equation of my graph? How would I note that?
No. That's in the absolute value.
Yep. In my absolute value, I'd have x. It's right, so I need to put a minus sign because it's opposite. So x minus 4 inside. And then it went up 3, so what do I do with that?
Plus 3.
Yep, plus 3 on the outside. And there's your equation of your graph. Now, I'm not inclined to give you a graph and ask you to write them in this way. So you don't need to stress over this part for the quiz. But that doesn't mean you're not getting 1 or 2 for homework. All right. 18. So, on this one, what do you notice about this graph compared to my normal absolute value graph?
It's a bit stretched.
Oh, it's down. It's not stretched.
It's just open down, so it's reflected. I see why you're saying that it kind of looks stretched because they took their 2 points that they put on the graph and they basically put a gap between them. So instead of it being at 1, 1 and then at 2, 2, they went from essentially, well, I'm just going to say from 0, 0 to 2, 2. But it's still a 1-to-1 ratio if you're looking at it. So if you go like down 1, right 1, down 1, right 1, you're still hitting the spot. So it's still just 1, increments of 1. I'm going to do 20 in a second, and I'll show you what it means if it's like compressed or stretched and how it would look on the graph. What else did you just say, Julia? Did you say something else?
Down 2 since it's reflected.
No. So that's a common mistake, though. So it's still wherever the vertex of that graph is moving, we would still classify it the same way. The only thing that reflected is telling us is that the graph has been flipped upside down.
All right.
So this one would still be up 2. But yeah, that's a very common thing people do. All right, so how would I write the equation for this graph? Y equals what?
X in the thingy. No. Something. Because I need something to be reflected. It doesn't matter what number it is, right? Doesn't matter.
Well, it would matter.
Yeah, it does. Hold on.
What'd you say, Cooper?
-1.
Yeah, so I can just put a negative. If you put the 1 there, that's fine too, but I can just put a negative outside of the absolute value where it was not working.
X plus 2.
Yep, and then outside is a plus 2 because it's going up. All right, 20. So this one is different. I'm going to try to put this one up here so that I can basically show you something on this one. All right, so 20, this graph is obviously over here, right? It's been shifted over. We'll talk about that in a second. But as far as telling if it's compressed or stretched, I'm essentially looking at the slope of the line. Now, I would recommend looking at the positive one so that you don't get confused. But I'm looking, if I just go up 1 over 1, well, that's not where my graph is, right? So this one is obviously either being compressed or stretched, and people tend to get confused when they just look at a graph of saying, oh, this is stretched or this is compressed. So what I do is I just look at the slope of the line and I write it that way. So this one, rise over run, is up 2, right 1. So that means that this one is stretched by a factor of 2 because the slope would be 2 of that line, of just that side. And that's the easiest way to look at it. So this one then I know is going to have a stretch of 2. So that would be what's going to go in front of my absolute value in a second. But what else is happening to this graph?
It's
Up
up
left
to.
It's up to, and there's something else. Yep, right 5.
It's 20.
Oh, were you looking at 19?
Maybe.
So 19 would be a compressed one. Because that one, if you look at the slope of that line, it would be up 1, right 2. So it would be a fraction. A fraction that's less than 1, I should specify. All right, so how would I write the equation for this one? Y equals what?
2, and then in x minus 5.
Yep.
No.
Yeah.
Yeah. Plus 2.
Yep. So we've got the 2 on the outside, inside the absolute value, x, opposite sign, so minus 5, and then outside same sign, so plus 2.
What was it exactly?
They're gonna do this. Yeah, my mom or something.
I didn't see
All right, look at number 30, so you'll have to flip there in your book again because there's a picture. 30, they say describe and correct the error in graphing y equals the absolute value of x plus 3. So what should happen to y equals x plus 3 inside the absolute value? Like what shifts should have occurred with this graph? Should go left 3. So what did theirs do?
Went up 3.
Yeah, they went up 3, so we would just say they went up 3 and should have gone left 3. So I'm not expecting you to re-graph it. I'm just expecting you to just state what should have occurred, essentially, with these ones. All right, any questions on this stuff? All right. So we've got problems. 5, 9, 11, 13, 15, 17, and 31. 31's a multiple choice question. Now what I'm going to tell you is both with 15 and 17, they are either compressed or stretched. So you will need to watch or look at the slope to figure out what it is to get that value. Tomorrow